Okay, I want you to look back at the 4 problems you just solved, okay? We had 4 times 12, 8 times 12, 8 times 6, and 16 times 6, or 6 times 16. What I'd like for you to do is I'd like for you to go back and look at those, and I want you to think about if you notice any connections, okay, between the expressions and the products. If you notice anything, go ahead and pause the video now while you're thinking about it. Okay, hopefully you've paused and now you're back. So just rewriting these problems and looking at them in a different way, let's look and see what we notice. We know 4 times 12 is 48. We know 8 times 12 is 96. 8 times 6 is 48. And 16 times 6 is 96. Patterns do we notice here? Okay. Well, the first thing I'm looking at when I'm looking at these equations is I notice right away that 4 is twice as big, or double this. So, I'm sorry, twice as small. So 4 times 2 is 8, right? Okay. I know there's a relationship there. I know when I go from 8 times 12 to 8 times 6, 12 is twice as big, or 6 is half as big, so it would be divided by 2 as 12. And 8 and 16, well, what they have in common, 8 times 2 is 16, right? Now let's look here at the products, because these numbers, once I find a relationship here, I mean 12 is the same, 6 is the same. What's happening here? So here, my answer is 48, and I've doubled 4 to get 8, and in effect, my product has also doubled, all right? When I go from 8 times 12 to 8 times 6, my product is divided in half, right? And once again, when I go from 8 times 6 to 16 times 6, my product has doubled. So the problems are kind of alike, okay? So the first answer might be doubled or halved depending on what your other factors are. I want you to be looking for those relationships as you are solving problems, okay? I'd like to do one more thing with this problem string, and it's going to be, I'm going to give you one by one some problems. So I have 12 times 8, okay, and I want you to draw an array for it. So 12 times 8, 12, we'll just say times 8. Look like this, right? And then I'd like you to draw an array for 24 times 4. All right, so if you made your array look a little bit more proportional, so it can't look exactly the same as 12 times 8, right? So this end would be twice as long, so it would be, right? And this side would be half as large. Okay, we know 12 times 8 is 96. I should have written that in. 24 times 4 is 96. Let's do 48 times, what do you think I'm going to multiply by? So look what's happening here. This doubles, 12 doubles, 8 is halved. 24 is doubled, 4 should be halved, right? 48 times 2. So now this side of my array should be twice as long, right? And this side of my array should be half as wide, right? So now I have 48 times 2, which is 96, okay? And then if I double and halve all the way down as far as I can go, 48 doubled is 96. 2 halved is 1. And that would make this very, very long, 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 and skinny. I'm having a hard time making this straight. This would be your 1 and your 96, which would obviously give you a product of 96, right? Okay, so here we go, and I can go up. So what I want you to be looking at here is the relationship between these arrays, how very similar they look. Some of them are a little easier than others. Now I know these are simple problems, but when we get into larger problems as we're multiplying in this unit, I want you to revert back to the doubling and halving strategy, okay? So when you double and halve using arrays, you can still use these same partial products to be able to do that, but your arrays are going to help you to visually see the differences, okay? Or numerical expressions, right?